I hope you received my recording of the previous class. So it's a good idea to check your emails, right? And sometimes it's very important actually because the college might send you some important emails, some other things. So it's a good idea that your email, of course, is given to the campus so they can always send you whatever updates. They don't send spam, so don't worry. You don't get emails from them too often, but it's good to be around with email. So anyways, the textbook is here, so we'll be using it. And I went to the to our IT department. Some people asked me where this was located. So let me get a campus map and show you. I should go ABC campus map. So we can get the clear idea. I'm sure you know where it is, but some people who are new to college may need a little help. And I just opened the Antelope Valley campus map. I guess the building that you all know, the admissions building, right? That's probably the first one you go to when you arrive to campus and start to register. So that's right here. And the yellows are the parking lots. So you can probably park someplace in this area that'd be convenient. And then here's the place where you can get a free computer. You need to go through these double doors right there. And the room is 113. I think I said 103 last time, but I was wrong. It's 113. Well, there is only one room there. So it's a big room. It has lots of workstations. So you can just, if you have nothing to do, you can just stop by and you will get a free computer with headphones. So you can listen to either lecture recording or to just watch some videos, some whatever. So it is convenient, and I hardly ever find anyone in that computer room. So you can always utilize it whenever you're on the break, you want to have good internet access. They have landlines, so that's a great place. Very friendly people. So I asked them yesterday if they still had this internet hotspots, and they said yes. Oh yeah, that's great that you created the group so you can work together. Thank you for sharing that link so anyone can go there, I guess, from our class. I'm not going to be on that group, so don't worry. But yeah, you can definitely work with someone else. It is helpful. So anyways, I was trying to say a location where you can get a free laptop from the college. They have plenty of laptops. And also they have hotspots. So you can get internet access, a free internet. But they say you need to fill some type of online application for this. And you can find it somewhere online. I think if I try HTTPS, I believe. Remember ABC, I think. Yeah, you need to go to the ABC website. They show me the address, but I may have a hard time. ABC, and then because I clicked on it once. So anyways, try contacting. So if you go just avc.edu, computer services. See, it doesn't allow me to go. I need to type it. But I'm sure you can do this yourself. Just go to the college website, and then once you're in it, Campus Life, that's the choice. Campus Life, that has a learning center. That's another place. It's in Sage Hall. That's where you can also have a free computer and the internet and just sit there. It's like, and there are also tutors. But the one that I'm talking about is here, IT services, so information technology. I hope you can see where I like this. So information technology. And if you're not on campus, you can always call them. I think that's the best thing to do. So you can call, here's their phone number, and they will definitely help you finding this. It's like a computer loan application form, something like that. So that's where you get this free internet. But please do it today, because they said that they running out of those hotspots. They're very popular. So they already rented out a lot of them. All you need is your student ID, and you need to fill out this application. I asked lady, oh, application, so that's going to take forever. And she said, no, every day I process all of the applications. So she, in the beginning of semester, is very efficient. So just fill it as soon as you can, right after class. And if you want to get a free internet, why not? Of course, if you tell them, I just want a free internet, I have internet, but if you tell them that, they probably say, oh, you'll be waiting, because there are some people that said that they don't have any internet. But I think it's very helpful, since college is willing to give you such a device. But again, the reason I'm saying all that is because it's limited. So it's not going to be there forever. It's going to go away, as they told me, pretty soon. So once again, the place where you need to stop by if you're on campus is shown here. It's in room 113, where it used to be old learning center, because now they moved it. So nobody is in this little part of the building. They moved learning center here to the Sage Hall on the first floor. Yesterday I went there. It's just a beautiful, nice building. And that's another place if you need computer with internet access. I think this place, MH, is open till 8 p.m. So all day long. They open at 9, I believe, and work till 8. I'm not sure about Sage Hall, if they also open till 8, but till 5 for sure. So daytime they opened. So if you ever have any trouble with internet connection, or if you need help to print something or to make a scan of your homework to send it to me or whatever, just stop by, and they will be more than happy to help, because they're very nice people. But you need to have your student ID, because if they help just about anyone, then, well, the Staples and Kinko's will run out of business, because everybody will come here because it'll be free, right? So that's great service we have. Of course, if you ask them for 1,000 copies, they'll start charging you. But I think I saw today message that first 40 copies is free every semester. So you can make quite a few copies every semester. I think that's a great thing to know. So anyways, I guess we're gonna start talking about the class. And before I do this, I wanna make another announcement. I put grades on the Canvas. So let me show you how to get them. If you ever went to Canvas, then you know, definitely it's not very hard. But if that's the first time, well, you open this college website. It's actually My AVC. You don't go to the college website, you go to your own, you log in. And then here's the Canvas. Somewhere should be on the left side among menu choices. Where is it? Here it is. You see, shortcuts, Canvas. So you can click on it, Or if you log in directly, that's same thing. So I usually go to courses, and then because I have plenty of courses, so I will go and select the ones on the very bottom. Those are the last ones. So I believe our class is Math 148 here. So you just click on that selection, and you see the syllabus that I put with the login for this class, which is here, right? So it's the same thing as I sent to everyone by email, but the reason I show it is because of grades. So if you select grades, you will click on it and you will see your current grade in this class. As promised, I put A to everyone. I know that makes people happy, but that's not the end of semester. So if it stays till the end of semester this way, well, I don't mind, that's great, because I think everyone deserves good grades. So if your grade falls a little bit lower, then you can always work it out. In fact, I even wrote, if you click on grades, you will see what I wrote. I recommend to do even extra credit exercises from our textbook. So let me share the textbook with link with everyone once again. I see that some more people just logged in, so you can have it here. It's the same textbook that we used last time, and that's the textbook I will be using from now on. So you don't have to use this link every time. Let me show you how to download it. So you click on this download. It asks you where, so I put it, let's say, in the desktop. How you wanna call it? Let's say business calculus, and click save. And you can see here on the left lower corner of my computer that the file had been downloaded to my desktop. So this way I can easily find it. So it's there. So please don't worry. I don't make you to download something nasty, because I just did this download myself to my desktop, just to make sure you trust that there is no problem with this file. So anyways, let me click on first section that we looked at last time and say a few words about the homework that you can do, as well as a few words about extra credit. Remember yesterday, oh, actually 2 days ago, we talked about the due dates for homework, and they due on the day of midterm and another homework on the day of final. So that'd be week 8 and week 16. So not too soon. And I ask you to do some of the odd number problems from sections that covered in class. So they should be similar to what I do in class during the lectures. And if you miss the lecture, if you're not sure, well, I sent you a recording of this lecture. So you can always watch it on a weekend, or if you can just go to this learning center, if you're on campus, have nothing else to do, but you just stop by the learning center or IT department, and they will provide you with computer, with a desktop, with big screen, so you can see everything in very detail. So for the homework, you do some of the odd problems, not all of them. So looks like for very first section, there is a bunch of exercises that I just highlighted, because I don't want you to do applications. They're word problems. They have some nasty looking numbers. So I never ask this type of exercises on the exams, and I don't expect you to do them. If you really want to, fine, do this word problem exercises, but I'm not gonna make you do this for the homework. So if you have exercises that end at the applications, well, then you can stop. So how many problems should you do? I would say 3-4 problems from each section that is covered in class. So far, I didn't cover anything. So I'm just telling how one should think of doing homework. So I would say try one problem, like say exercise number 9, because looks like all of these exercises, they deal with so-called linear equations or equations of line. If you remember what that means, it's an equation that has only x and y in it, and no such a thing as x squared or y squared, so no squares, just x and y. So that's why first group of problems, they all have lines, so you can do one of exercises from this group, that should be good enough. And the next group of exercises, you have x squares, something like that, so you can do another exercise with the x squared, like that. Odd problems, so you can check the answers in the back of the textbook. And if you didn't get the same answer, well, ask me next time. So that's why for homework, I suggest to do odd numbered problems. And then you can do another one with x cubed. So let's say 3 problems here will be good enough. In fact, why don't I do them for you right now? So that'd be your homework. Now, if you want to improve your grade, if you want to do extra credit, that should be a little bit different. That should be even exercises. So you can also do some even problem, let's say exercise number 20. And that'd be an even problem, so that's extra credit. So you can do this on the piece of paper, make a picture or scan it, and email it to me anytime. Anytime you feel like doing some extra credit problem, just send it to me by email. Why? Well, because you will have extra points. So if your grade should fall lower, if your quiz grade, the class grade should fall lower, then hey, well, send me a few extra credit problems. That's what I wrote in that Canvas, and it'll go back right away. And I think it's much easier to keep the grade at the level you want. So if you say, well, A is too much, I'm fine with a B, or somebody can say, Alex, I just want to pass this. I don't care. I don't have time for all that extra. C is good enough. Okay, so just don't send me any extra credit. So it is your choice. Again, that's extra. But those are even problems. Homework you should do because that's part of the class assignment. But extra credit, like I circled even problem 20, for example, you may do 2 or problem 4 or problem 6, any even problem. I'm not telling you which one. So if you don't like some exercise, I'm not asking you to do something you don't like. Just look at the problem. You think, oh, I can do problem number 2. That's pretty straightforward. Okay, do this number 2. It's fine. It's up to you. Your choice. So anyways, last time we talked about the graphs of various functions, and we actually graphed the line that was provided in the equation, in the example, in the beginning of this little section, R. It's a review section. So let me take a look at exercise 9 that also deals with a line that has equation 8y minus 2x is equal to 4. So let me try to graph the line. And of course, I want to realize that to graph line, all I need is a pair of points. So just 2 points. So people usually create a little table. So they have pairs x and y. And convenient number that I can use is number 0. That's my favorite number. So I will try 0 instead of x. Of course, one can say, Alex, why you use 0? Why don't you use 1 or 2? Well, you can use any number you like. It is really up to you. When I use 0, see what happens. The x turns into 0, so that minus 2 times 0 will be still 0. So I'm going to end up with only 8 y's on one side and 4 still on the other side. So when I find y, I'm going to divide on both sides of this little equation by number 8, and I get 4/8. I say, Alex, this is a fraction. Well, yes, but you can take a calculator and divide 4 by 8, or I know that some people can definitely reduce it to 1/2, right? Or calculator will tell you that 4 divided by 8 is 0.5, which is same as a 1/2. So what I just did, I calculated point on the plane of coordinates, and this point is right here on the y-axis. This point has x coordinate 0 and y coordinate 1/2. And it's very convenient to use points for graphs that are on the either x-axis or on y-axis. So so-called intercept with y-axis is always going to be a point with x coordinate equal to 0. And similarly, I can use 0 instead of y. So this way I will find the intersection of my line with a x-axis, with another axis. And that should be good enough for us to get a graph. So what I'm going to do now is use a 0, but instead of y here, so I'll put it here in the equation. So 8 times 0 is going to disappear. So what am I going to be left with? Well, looks like I'm going to just have minus 2x on one side and 4 still on the other side. And notice that if I multiply -2 by another -2, right, I'm going to get a positive 4. And this tells me that x-intercept is -2. So -2 someplace here on the x-axis, which is going to be point with coordinates -2 and 0. And I just found second point. So that's all I need to get a graph of line, and I can connect them and produce the line. Please notice that it doesn't really matter what points you use, because the line will be the same. And how many points you use. I don't want to do more point calculation. 3, 5 point, 2 is just enough, and I've got line. And the key part of this exercise is to realize that the best points to use are ones that belong to the x-axis or to the y-axis. X-axis means that y is 0, and y-axis means that x is 0. So I've got the line. Let me try another one, number 13. So I will do homework. So basically those are homework exercises just to illustrate how we do homework for this class. So it hopefully be clear. So number 13, another odd exercise, which is y equals to x squared minus 5. So x squared minus 5 deals with parabola x squared. Did you ever see the U-shaped curve that we call parabola? That looks like that somehow. It's symmetric through y-axis, right? It's like a letter U. So it has equation y is equal to x squared. And we call it as parabola. Well, notice that in exercise number 13, there is a 5 subtracted from my graph. So turns out that when you subtract some number from that x squared, it means you bring the graph down 5 units. So now instead of having this lowest point that sometimes people call vertex at the origin at point 0, 0, the whole graph just dropped down 5. So every point went down by 5. That's what happens when you subtract 5. And it doesn't really matter if you subtract 5 from the x squared, or like in exercise number 21, if you subtract it from x cubed. Look at this. In exercise number 21, maybe I'll do this on the other side. So that's going to look nicer this way. Let me clear this. Number 9, and in exercise 21, please notice that I can bring my number 1 over to the other side, because we always try to have y on one side and everything else on the other side of equation. So what I'm saying is y should stay on the left, and then x cubed and minus 1 should be next to it. So please notice that similar to previous problem where I subtracted 5, now I'm gonna have to subtract 1. And to subtract 1, I'm gonna bring the graph down by only 1 unit. And the graph will be of a cubic parabola. Did you ever see that before? The graph of y is equal to x cubed. So this is the graph I'm going to be working with. So when I need to subtract 1 or bring this whole picture 1 unit down, so it's going to be something like that. It's equation of, and it's actually graph of equation x cubed minus 1. So it went down. If it was plus 1, you would bring it up by 1. You move it up. So that's how you do homework. And please keep it in one safe place. So this way you're not going to lose it. And that's important, right? Because then you're going to make pictures and then send it to me. And I'll tell you when. Well, you already know when, on the day of the midterm. But main idea is to do not just one section, but more sections. So I don't want you to send me your homework right now because it'd be very hard for me to keep track who sent me this section, who didn't send me that section. So it'll be a huge mess. So just wait till due date and then send me the whole thing. So anyways, we'll talk about it. Let me do problem number 20 here. I think that's another interesting exercise. So that's not for homework. I said it could be a extra credit. So what problems to do for homework? I already put it in the syllabus. 3, 7, so plus 4, 11, 15. But what I'm saying right now is you don't have to do that many. What you can do is just a few problems from each section. So that's all it is. So yes, they all due on the day of the midterm, which is also in the syllabus. I believe it's October 4 or something. So it's going to be in a month and a half. Yeah, you don't have to do all of them. That's what I keep saying. You know, it is up to you how much homework you want to do. Some people that want to get a good grade on the class, they do more. Some other people that say, Alex, I just want to pass it. Well, it's okay, you can do less. So it's your choice. So if you are doing great on the homework, I'm sure your grade on class is much higher, right? If you do more, it's always like that. So now I give full credit to everyone for homework, even if you did just few problems. So I'm not downgrading anyone on the homework, because when I get it, I get so extremely happy. I give you full credit for the homework right away. So even if you did much less, it's still going to be a full credit. So it's always the full credit. You just need to send it to me. That's basically the idea. So you should not worry about that. You just need to send me your work. You may not do it right. It's fine. As long as you attempted the homework, it's already a credit. So I would say that's just a giveaway points for the homework. And I want to support your doing something for this class without any panic. So you know that I'm not going to really care if you did it right or wrong, as long as you tried, because that's a homework. But what I'm saying is I will help you with homework at the beginning of every class, just like I'm doing right now. So basically I'm doing homework for you, right? So now you know how it is structured. So I'm not asking you to do like 3, 7, 11, so many, because we notice they're pretty much same problem. So you can just do one line and that's good enough. It's a little shortcut. I know some people say, Alex, you know, it's just so difficult for me. It's like too much. Well, redo the same problems I done in class. And that's good enough for the homework. So you don't have to do those every other odd or something. Just do stuff that I did in class on a piece of paper, because you will see how I did them in the video of the lecture, right? Because I record all that. So you can just redo this after class and you're fine with homework. So that's another alternative. If you don't feel too good about math. I know some people just not very good at it. So you can just redo the same problems as long as you practice. That's the key idea why I assigned something to do outside of class. So just some practice. Once you did some practice, perfect. You already get 20% of the course credit. How about that? I think it's a good deal. But again, if you want to ace this class, if you want to take some more classes related to business type of calculus, economics and stuff, well, then definitely you want to do probably more for yourself, not for me. For me, it's enough that you just try something. I'm just trying to give you an idea that everything be fine. Just try to do a little bit of these problems. And don't worry. So anyways, let me try exercise number 20. And that exercise has negative x squared in it. So how does the graph of negative x squared looks like? And turns out that negative in front of x squared will make parabola flip and open downwards. So that positive x squared that you see down below and negative x squared, they pretty much same graph, but reflected down. So when I have to graph something like y is equal to negative x squared plus 5, I say, Alex, wait a second. Are you sure this is exercise number 20? And the answer is yes. I just wrote it a little bit differently so it'd be more convenient for us to see what's going on. So that 5 I can put after the negative x squared. It's positive 5, so I put plus 5, which means I moved this graph upwards by 5 units. So the graph went upwards. And that's the graph. And that's it. So it's pretty much same type of exercise. I know 20 may be a little bit too much, but I think for extra credit, probably like 2 or 4 or whatever else you like here could be perfect. So anyways, let's see what else we have here in this review chapter. Again, this is a review. This is a refresher. You probably already learned this before. If not, well, you have a good chance to learn this right now, because what I do is don't go through every single little exercise in this review. I just select what we really need for the calculus class. You say, well, looks like it's a review for the whole book. Yes, but we're not really going to cover the whole book. That's the point. We always cover just a few chapters, not the whole thing. So that's why I select not what we don't have to, but what we really need to do. So the next section is called with word functions. And I already used this word functions. And turns out the only thing that this section does, it simply replaces the y in our equations with f of x. So that's really the only thing that this section is talking about, which is, I think, pretty nice. So we'll be working with functions. Instead of y, we put f of x. Well, sometimes we cannot do this when we don't have a y, but y squared. So notice that in example 3, for example, we have, instead of y is equal to x squared, now it's f of x. So it's a function of letter x. I'm sure you saw this before, right? They like this f of x or g of x. They call them usually those functions with letters f and g. So functions that we have here, again, we're going to be very selective for the exercises. Here's the graph that I'm sure you recognize from the previous section. X squared minus 1. Now it's not y, but f of x, right? And you can see parabola that was shifted down by 1 unit because of that minus 1, right? So minus 1, so you bring this down by 1. Okay, so we have function. When you say, Alex, what is not a function? Well, not a function is right here. The graph of x is equal to y squared. So I know that this is not a function simply because y is squared. So whenever you see something done with y, then it's not a function. And they actually produce the graph of it here. They have here on the page, the graph. Well, you can intuitively see why this is the case, because if I take my favorite parabola, y is equal to x squared, and then it looks like we have to switch x with y, right? So you put y squared on the other side, and instead of y, I put x. So if I switched x and y, then I probably should have switched my axes, x and y, but the axis we never switch because x-axis is always horizontal and y-axis is always vertical. So what I should do is switch the graph. So instead of graph opening along the positive direction of y-axis, it actually opens along positive direction of x-axis. So this is parabola, but just goes to the right, along positive direction where arrow points along x-axis. So that's what actually they have produced here for us on the textbook. And they said that this is not a function because so-called vertical line test that fails it. So if you can find vertical line that hits your graph at more than one place, like here they show 2 different points, well, this is not a function. Vertical line test for the graphs. I hope you also heard that vertical line test. So for example, here's not a function because in the exercise in the picture B here, we have not a function because vertical lines intersect at 2 points. When you say, Alex, but this vertical line intersects only at 1 point. Well, if you can find a vertical line that intersects at 2 points or 3 points, then it's not a function, if you can find. So in the next part, C, it's not a function either, right? Both of these graphs are not functions because I can find vertical line that intersect at 2 points. So that's so-called vertical line test. And other than that, section does nothing but instead of y puts f of x. So that's, I guess, something that I don't want to worry much about. So you can kind of disregard these exercises because it's just y replaced with f of x. So this section is pretty short, so you don't want to worry about it probably. And the next section will be important. I don't want to overwhelm you, so I'll just take a look at section 3, and that should be good enough. And then we'll have a little quiz, as I promised, at the end of the class. So please don't go away. We'll have also some fun at the end. But let me do a couple of problems here first. So this section talks about so-called inequality notation. So it turns out you can write the same thing differently. So for example, they give you here interval on the number line, the picture from A to B, and points A and B are not included. So they're like open circles here. But you can also write this with inequality. You can say everything from A to B without including A and B. So it's the same thing, but it's written differently without a picture. So you say, Alex, how should I write it? It doesn't matter to Alex. Just write something I will understand. So don't worry. I'm not picking on people because they wrote it this way and I want it this way. So that usually happens when you take tests in this special software type of packages. You probably encountered that math lab where stats crunch, some other things. So I don't want you to buy them because they're annoying. You solve the exercise correctly, but then you try to put your answer in that program and it doesn't go through because the computer programmer had something else in mind, even though with math is fine. So I care for math. I don't really care how you enter your answers in the program. So you just write it on a piece of paper and I will understand. No worries. So example 1 here shows that interval in between of -4 and 5 could be put together, like make a bigger picture. -4 will have point here, +5 is to the right, and everything in between, and that's how they expect us to put this interval here. When you say, why did they use parentheses here? Well, they use parentheses to show that -4 and -5 are not included, so they put this in the parentheses. So that's what it is. Okay, so this is our answer. I say, what about this part B here? Looks like x supposed to be greater than or equal to -2. So let's try that one. X is greater than or equal to -2. Let's picture that. Well, I put -2 on the number line. Now I will include it. So I'm going to fill this little circle like that. And x should be greater. X should be all the way to the right. I say, Alex, how far to the right do you go? Do you just keep going and going? You're going to infinity. So you can write it from -2 all the way to the right means to infinity. Did you ever see that symbol? It means you go infinitely. But please notice -2 has to be included because there is a equal sign. You see the difference? In the previous exercise, we have open circles, no equal, but now we have equal signs. So this circle is filled up. So you really want to fill this circle up. When you say, Alex, maybe enough? Yeah, maybe enough. So it's filled circle, it's included. And then -2 will be in the brackets, just like that. Okay, so looks like it's another little notation. So it means that we actually wrote same thing 3 times. Once with inequality. So the first one, inequality. Second, I made a picture of that on number line. These two are the same. So if you write inequality or if you make a picture, it's the same thing. And there is a third way with interval from -2 to infinity. So usually in the answers, they give you intervals that look like that, usually. But whichever way you put your answer down is fine with me because they all mean the same thing. So I just wrote the same thing, but 3 different ways. Okay, so that's good to realize. So when I go to the section end, this R3, the section end, so I need to just go through all these examples, you just keep going. Oh, exercise set. So you can see a bunch of exercises with this various intervals here. So you can try one of those if you want to. Now there are some pictures that I don't worry about. I think I will be concerned with word domain. So the group of exercises that appears here on this page 32 looks like. So let me do a couple of problems here because they're very interesting, I think. Word domain is one of the key parts when we graph our functions. So we need to know what are the possible x coordinates of the points. So I'm looking at exercise 33 right now, and I'm gonna see that we divide for this function f of x, or you can just put y, same thing, is equal to 6/2 minus x. So what I do is look at the fraction and say to myself, Alex, you cannot divide 6 by 0. This is a bad idea. I say, Alex, why? I can divide, I just take it and divide it. Well, let me show you why you cannot by utilizing a free calculator. Let me show you another tool that we're going to use here. I just type scientific calculator. Please notice I start typing and it appears scientific calculator. It's a very popular choice. So once you find one on Google, well, I don't want to use this Google built-in calculator. I want to use first choice, which is called Desmos. So when you click on that calculator, I think it's very, very convenient one to use, because when you divide 6 by 0, it nicely shows you what you're actually doing. And you can see that this is not possible. We don't divide by 0 because this is a bad idea. We never divide by 0. Which means that when I'm looking for so-called domain for this function, I want to make sure that my denominator 2 minus x is not equal to 0. See, denominator cannot be equal to 0. This means that if I bring x to the other side, x is not equal to 2. I say, okay, Alex, so x is not equal to 2. So what is x? What is it equal to? Well, it's equal to everything else. All real numbers, everything on the real number line. So from 2 to the left or from 2 to the right, just not 2. So all real numbers but 2. Please notice I just wrote same thing again, but with a picture. So you don't have to do it. It's good enough just to say what x is not equal. So automatically people know what x is supposed to be equal. Everything else on the real number line. Let's try one more here. How about, where's the textbook? How about exercise number 36? In exercise number 36, it's a little bit different. We have a square root. So for exercise 36, we don't have any denominators, but we extract in square root from x minus 2. So that's our function, let's say y. Well, question is, can I square root something like -1 or -4? Well, ask your new little friend this scientific calculator. I'm going to click on it and just enter that. Go square root here, -1. So please notice this is a very convenient calculator, because that's the one we use in statistics classes, where we calculate very big expressions, fractions, there's square roots, lots of stuff in one calculation. And the good thing is it shows you everything in front of you. If you like some other calculator, it's fine with me. If you want to use something you have, it's fine. But I will always utilize this particular calculator to show everything for in class. So anyways, square root -1 is again not defined. Or if you want to calculate square root -4, look at this. I can just add it. I just click where -1 is and replace it with -4. So it doesn't matter whether you have -1 or if you have -4, it's still undefined. So this tells me one big thing, that whatever I have here inside the square root cannot be negative. So when we start to look for the main of this function, we say that x minus 2 is not negative. So it could be either greater than or equal to 0, not negative. So when I need to get x out, I just bring the 2 over to the other side. And here's my domain. X is non-negative. So it is greater than or maybe equal to 2. And that's another case that we consider here that is related to domains of functions. So if you have issue with denominator. That's one place to worry about. And the other is when you have a square root. You want to make sure that square root you do not extract from negative numbers. And that's about it. So let me try another exercise. Let's say number 40. Try to find the domain for exercise number 40. It looks like it has an issue with its denominator, right? So the function f of x, which is 8 divided by 3x minus 6, has denominator. So I want to make sure that my denominator is not equal to 0. So right away, I just write down that 3x minus 6 is not equal to 0. So what about x? Well, let me solve this for x. As usual, I bring 6 to the other side. Minus turns into plus, right? Change the signs. And then to get x, I need to divide both sides by number 3. So we end up with a letter x, which is not equal to number 2. And that's it. Looks like that's it. Their favorite domain, right? X is not 2. When you say that one was 2 is not it. Well, x is not equal to 2. You can put one way, or 2 is not equal to x the other way. It means the same thing. So domains, we care about denominators not being equal to 0. So now, why don't you try one exercise for a quiz? Something very, very similar to what I just did. Can you find the domain for exercise number 34, please? And put your answer here in a Zoom chat. Now, please don't hurry. You have plenty of time for that. Don't hurry. What you want to do is put the answer in a Zoom chat only to my name, only to Alex. So don't send it to everyone in class. Just send it only to me, to Alex. So you need to click on this where 2 is and select only my name and put your answer. So quiz is exercise number 34. That's actually a quiz for today. So just one exercise. I never give more than one exercise for the quiz, just one. And I expect you to put the answer, just the answer. You don't put solution of the whole thing because it's very hard. I just want to know the answer. That's why for quizzes, I always put pretty straightforward little questions, so you just get the answer. So what is x not equal to, or whatever. So you could write it with words or whatever. I will understand. So please don't hurry. And after you're done with this, well, you can relax and enjoy the rest of the day.